Hi, and welcome to Rubel's Rambles here at the Maycomber Center. So, yesterday, May 30th, Mars made its closest approach to Earth since 2005. As you hopefully knew, Mars had reached opposition, where it was opposite the Sun in our sky on May 22nd, but it's going towards its closest point to the Sun very quickly, so quickly that its closest approach is after its opposition, because its orbit is so elliptical. But another planet, Saturn, is having its opposition on June 2nd, which I believe is Wednesday night. No, it's Thursday night. On Thursday night, Saturn will be at opposition. So it'll be well placed for viewing. It will rise at sunset and set at sunrise because it's opposite the sun in our sky. And so if you go out at like 9, you should be able to find it. But I'll talk about that later. So, there's a thing with all these oppositions. There's a thing called opposition effect, where stuff will get a lot brighter in the few days surrounding opposition. This happens with the full moon too, except it moves so quickly around its orbit, it's not a few days, it's a matter of a few hours. Basically, every tiny particle of dust, usually when you're seeing it from a slight angle, you see some shadow. So the disk is, you can't see any of the shadows, but the shadows do add up and make it a lot less bright. But at opposition, there is no shadow, so the disk is completely illuminated without those tiny shadows. And so you'll see a sudden brightening that should be, if you observe something like Saturn right now and then keep looking at it every night for like a week or two, you should notice it dimming, opposition effect wearing off. If you have a telescope, this is especially noticeable with the rings, which are actually made of a bunch of small rocks that can be pretty big, but also most of them are pretty small. And so they usually have a lot of shadow, but right now they don't because of opposition effect. So how can you find Saturn and Mars? Well, if you go out around 9:30-ish and look to the southeast, your sky will look like this. You can see that Saturn and Mars are making a triangle with a star called Antares, which is a giant star, and its name means like Mars, or the rival of Mars, because it, as you will be able to see, it's red, and Mars, while it's low in the sky, looks pretty red. When it gets higher in the sky, it gets so dazzlingly bright now that, to my eyes, it doesn't look red anymore. It just looks whitish, orangish. But if you catch it fairly low in the sky, it should look red, and Antares will look red. And yeah, so you can see that. So another thing that happens at opposition is retrograde motion. So imagine you're walking past someone who is barely moving. So it's a little hard to imagine. You probably have to actually do it to imagine it. But so for most of the time, they'll look like they're moving forward relative to the background. But as you pass them, they will appear to move backwards against the whatever the background is, the houses or sidewalk or whatever it is. And so that happens with planets too. Usually they move they appear to move in our sky just around in a circle, but every opposition, when Earth passes them, they experience what's called retrograde motion, where they move backwards against the stars, or they appear to move backwards because Earth is passing them in its orbit. So if you picture, here's the outer planet and here's Earth. Earth's line of sight, if you drew a line connecting the two planets and extended it out, when Earth swings by it, the end, which is what the background stars we're seeing it against, moves backwards. But then as they orbit, it'll move forwards. It's a bit hard to explain, but if you go outside and you look at where the planets are, and then you look a day later and you keep looking, you will notice the retrograde motion. Mars's will be a lot easier to notice because it orbits so much faster than Saturn. But so you'll also be able to see the triangle with Saturn, Mars, and Antares stretching and warping as both planets move around the sky. So now there's one small bit of breaking news. 35 million years ago, in a galaxy far, far away, named M66 or Messier 66, a star exploded in a supernova. And just now, that light is coming to Earth. So if you have a telescope, I'm not sure how big it has to be. I will try to look at it tonight, and if I can figure out how big a telescope you need, I'll comment it on the video. But I'm not sure right now how big a telescope you need. But try look at the galaxy. It'll just look like a star that's not usually there. Or maybe you won't be able to see it. I'm not sure, but I will try and let you know what happens. If you need to know how to find M66, you can probably get finder charts online, or the app Sky Guide will help you find it. So, yep, yeah, that's it. Thank you so much for watching. If you have trouble finding any of these things, ask me, and clear skies.